I'm going to continue with my examples. Again, honestly, the best thing that you can do when you see overlapping triangles is to separate them so that you can see them more clearly. Okay? So I've got, let's see, I've got one pair of sides, the ones that are marked with a single. I've got a second pair of sides. Those are the ones that are marked with 4. And then the last thing that I have to care about is this last side, BC. But I know that BC is congruent to BC by reflexive property, just like on the last one when I said that AC was congruent to AC. So then I've got a mark of 2 here. Why not? And so I know that triangles A, B, C is congruent to triangle. And again, I need to make sure that they line up. So AB is the one that has a single mark. So I need to go D, C, and then C to B. The last one is B. Yay. Okay. So I know that they're congruent by side, side, side. Because I've got side, side, side. All right, last but certainly not least, these two triangles. So I've got a single side on both outsides. Oops, a single side marking. And then BD is congruent to BD by reflexive property again. Reflexive. So I'm going to put 2 marks here. But I don't have anything to indicate that AD is congruent to CD. So these are not congruent. By SSS. I need that last side length. All right. Any questions you have, please make sure that you make note of them or ask them. I'm going to start a new page. So make sure you pause this and you have that written down. Okay, I'm going to start this page with that hint from last page is when you see overlapping triangles, redraw them separately. It's like the most helpful thing that I ever learned, and I know that it helps so many people understand what their triangles are supposed to look like. Don't be afraid to redraw it. You have a piece of paper and you've got that the triangle puzzle there. Just redraw it on the back side, on the side, on your own paper. It doesn't matter. Redraw it. Use your math notes to redraw those things. It's going to be so helpful. Okay? All right. So we know side angle side. We know side, side, side. We know both of these are congruence theorems. So there's another congruence theorem. It's called side angle. And this is one of the few, one of 2 that do not work. Does not work as a congruence theorem. Okay. And that's because the 2 sides could be connected by any angle. Like, get 2 sticks of any length, connect them, right, at any angle. Well, just connect them, and then have a third stick, and then move the angle or whatever. You're going to notice that you can make infinitely many triangles. Okay, side angle does not work. Please make a note of this because this is very important. You're going to see plenty of triangles that have side angle. So an example of side angle is side, and then angle. Okay. Remember, it's not the included angle. It's the one outside the angles. This never works. There's no way to prove that those 2 triangles are congruent. Okay. One easy way to remember this is that side angle spells the naughty word backwards. So I always spell it side angle. The books are always going to do it that way, but that's how you can remember that one does not work. And the other congruence theorem that does not work is angle. Does not work. Okay, and this is because if you just have the angles, then you could stretch or shrink it. It's kind of like when we used dilations in the last chapter. You can make that triangle as big or as small as you want. It does not work. It will not give you congruent triangles every time. Okay,